limiting reagent question here, so let's take a look at it. The first thing we want to do with basically any chemistry question is to start with the balanced equation. And so here we have calcium phosphate plus sulfuric acid, which gives us phosphoric acid, which is one of the products that it tells us. The other one you can get by simply foiling. This is a double displacement. So that's the first one, and that's the second product. So in this case, it's going to be calcium sulfate, and the charges are already balanced on that. So quickly taking a second to balance the chemical equation, which we're going to do with a 3 there, and a 3 there, and a 2 there. So that's step number 1. Step number 2 is going to be converting all these grams into moles. So we'll start with calcium phosphate. So 103 grams of calcium phosphate. I do this with crossbars, but you could obviously do this with a cross multiplication. So we're going to be dividing by the molar mass, which is 310.18. You could obviously get that by just adding up all of the elements in calcium phosphate, the atomic mass of all those elements together, but I've done that ahead off screen. So dividing 103 by their molar mass gives you 0.332 moles of calcium phosphate. And then doing the same thing for sulfuric acid, so 75.0 grams of sulfuric acid. Molar mass of that is 98.079. Dividing those gives you 0.76 moles of sulfuric acid. So now we know how many moles we're dealing with. We need to find the limiting reagent. So the limiting reagent essentially is just when you have two reactants, unless you have exactly the same number of moles that you need in the mole ratio for them to go to completion, which is to say all be used up in the reaction. If you don't have enough of one of them, then the other one is in excess. And so there's going to be some leftover after the reaction because there wasn't enough of the other thing to react to it. And so the way that we do that, that we find that, is we can see that for every 1 mole of calcium phosphate, we need 3 moles of sulfuric acid to use up all of the calcium phosphate in this reaction. And so using that mole ratio, all we have to do is multiply our 1 mole of calcium phosphate, just gonna by 3 because of our, again, our mole ratio, and that's like 0.9 something. So basically what this means is that if we have 0.3 moles of calcium phosphate, we need 0.9 moles of sulfuric acid to make the reaction go to completion, and we don't have that much. We only have 0.76. So because we don't have enough sulfuric acid, we can say that the sulfuric acid is the limiting reagent for this problem. So just cleaning that up a little bit. So basically now that we know that sulfuric acid is our limiting reagent, we don't even have to worry about this anymore for the rest of the problem. So we're going to be dealing with this 0.76 for the rest of the problem. And now we're going to take into consideration the mole ratios of the products and the reagents, the reactants in the products. So we know that looking at our coefficients here, that for every 3 moles of sulfuric acid, we produce 2 moles of phosphoric acid. And so when you multiply this 0.76 times 2 divide by 3, what you end up with is 0.51 moles of product. Basically what just happened is we know we're dealing with 0.76 moles of our limiting reagent, and so when all that is used up in the reaction, we're going to end up with 0.51 moles of our product phosphoric acid. And so then from that, so that was our step 2. This is kind of our step 3 right here. And so now we can just convert this product into grams, and we will be done. So for every mole of phosphoric acid, the molar mass is 97.994. And so we're going to end up with 50 grams of phosphoric acid as our last step. So quickly recap, start with the balanced chemical equation, convert all your grams to moles, find your limiting reagent, use the mole ratio to find how many moles of product you're going to get, and then convert the moles back into grams. And that's how you tackle this question. I hope it made sense. If you have any additional questions, feel free to throw them in a comment down below, and I'll take a look at them. Thanks.